Hello everyone, my name is Mansiba Gohil and in today's video I will be solving some of the GET questions in the topic Design and Analysis of Algorithm under the subject faculty of Nishit Kotak sir. So the first question is, which of the following sorting algorithms has the lowest worst case complexity? So in order to know the complexity, we first need to know each of these sorting algorithms and what actually is a sorting algorithm and what does the worst case complexity mean. So I have written here some notes. So sorting algorithm are used to arrange a list of items in a certain order. And how do you find the complexity? So complexity is basically a number which can be known by the number of operation it takes to sort an item in a certain order. The lower the complexity is, the faster the algorithm will be. So solving each of these sorting algorithms complexity, first we say that what is a merge sort. So merge sort is kind of a sort which takes help of divide and conquer approach, which works as dividing a list into smaller sublists and sorting those sublists and then merging them back together. So if we say that the worst case complexity of it will be O n log of n. The next option that we have is the bubble sort. Bubble sort is a simple sorting algorithm that works on repeatedly swapping adjacent elements. If they are in the wrong order, then it will continue doing until they are in the sorted order. And the worst complexity of it will be O of n raised to 2. Coming to quick short again uses the rule of divide and conquer algorithm that works by selecting a pivot element and partitioning the list around the pivot. It has the worst complexity of O of n, but we can say that its average complexity, meaning that the average level case would be O n log n, same as the merge sort. Coming to selection sort is a simple sorting algorithm that works repeatedly by finding the minimum element in a list and moving it to the beginning. It has a worst complexity of O of n raised to 2. So as we compare worst case of each of this complexity, we come to know that the lowest one is of merge sort. And we always need to remember that we can find this complexity based on the number of operations, and the lower the complexity will be, the faster algorithm will be, and the more easier the more beneficial it is for the algorithm to have the lower worst case complexities. Coming to our next question, the in order and pre-order of binary tree are DBEFCG and ABDEFCG respectively. What would be the post order of the binary tree if we are supposed to guess? So we right now has the pre-order and the in order of both of the binary tree. So we need to remember something, okay? Let's just say that in order to find the pre-order, we there are three rules. If it is a pre-order, then it will be root, right, left. If it is in order, then it would be yes. So as I was saying, if it is a pre-order, then it will be root left right, not root left right. So the correct one is root left right for the pre-order. If it is in order, then it would be left root right, and post order would have left right root. You can remember it as, if it's in order, then the middle part would be the root. If it's pre-order, then the root would be at the beginning, and if it's post-order, then the root would be at the end. So as we have this information, we can see here that D, B, E, F, G, C, G is the in order of it. So D would be the root, B, so here it is. It is the structured in such a way that we can find from this tree only the in order, pre order, and post order of it. Coming to the next question, consider the hash table of slide 7 with starting index 0 and which has the function of 3x plus 7 in mod 7. So assuming the hash table is initially empty, which of the following is the contents of the table when the sequence is 1, 3, 8, 10 is inserted into the table using closed hashing? So first we need to understand that what is the size of the table which is given in the question, which is 7. And using the closed hashing method, we just need to take the mode of the numbers that we have right now. So we will use the function that we have. So it would be 3x plus 7 modular 7. Sorry, 3x plus 4 modular 7. We will be exchanging x equal x by 1 for the first time. So h of 1 equals to 3 into 1 plus 4. So it would be 7 modular 7, which is 0. And as it is the empty loop, empty array, we would be inserting it as the 0th position. Next, coming to the third, and as we do the calculation for the function, we would have 13 modular 7, which is 6. So we will insert it as at the 6th position. Coming for the next element, which is 8. So 3 into 8 equals to 24 plus 4, which would be 28 modular 7, which would again have us the which will again leave us with the modular 0. But we already have given 0 and we have inserted it at 0th position. So that position is already filled by element 3. So we need to insert it at the next free location, which would be the first location. Now for the next element, which is last and which is 10. So we again use the same formula and we are left with 34 modular 7, which has the answer 6. Again, 6th position is already filled with the element. So what would be doing? We will be inserting it at again the next free element, which is the second position, which leaves us with 1, 8, 10, 3. So the correct answer for it will be B. Coming to the next question. In an unweighted, undirected connected graph, the sorted path from a node S to every other node is computed most effectively in terms of time complexity by. So first we need to understand that what is a connected graph, what is undirected graph, and unweighted graph. Connected graph means that there should not be any single node which has or disconnection or is not connected to any other nodes of the remaining portion of the graph. Undirected means basically means that there should not be any certain directions provided. For example, when we are talking about the maps or structures on social media, then they would be directed graph because they would be pointing at a certain direction or certain connection between each of these nodes. As in LinkedIn, they have first network, second network. So that would be the examples of directed graph. Here we are talking about undirected graph and unweighted graph, meaning that the vertices should not be having any weight in the whole graph. So what would be doing? We will be performing different kind of methods that we have given and analyzing them. Performing a BSS from starting from S in an unweighted graph. Performing a BFS starting from S takes of n time if graph contains n vertices. So this is the complex time complexity that we have for BFS. Digestra's algorithm, if I'm not pronouncing it wrong, Digestra's algorithm only finds the single source and it finds the shortest path, which again takes more than the BFS, which is of n raised to 2. But it is good if we are talking about directed graphs. Varshaw's algorithm for all pair it finds the shortest path again same as the Digestra's algorithm, and it has the time complexity of O raised to of n raised to 3. So again same thing, it would be good if it's a weighted graph. So for the examples that we have right now, and performing a DFS graph will again give us time complexity of n raised to 2, which is still less than BFS, which is still more than BFS, and we need to find the complexity which is most efficient. So we need to find the one which is lesser one, which is most least one. And here we can see that BFS graph is the most least complexity out of all. So the correct answer will be B. Performing will be D. Performing a BFS starting from S node. So thank you all. That would be all from my side.